Hello, thank you for watching this video. So in this video, I'll be doing question 7 of May, June 2023 question paper, mathematics paper 1. And these are derivatives. So let's go. 7.1. Determine f prime at x from first principles. If it is given that f of x equal to negative 2x squared minus 1. So they want you to find f prime from first principles. If you are given that f of x is this. So, first question, what do they mean from first principle? So, they want you to find f prime, which is the derivative of f, using the derivative definition. That's what they're saying. So, when they're saying find these derivatives from first principles, they're saying use the derivative definition. So, what is the derivative definition? You know very well that the derivative at x is equal to the limit as h goes to 0 of what? Of f at x plus h minus f of x all over h. So this is the derivative definition, first principles. That's what they mean. So, no problem. So, to use this definition, we need to have f of x, which we do have, and we need to have f at x plus h, which is what we don't have. So let's go and find f at x plus h. So f is a function of x plus h is equal to what? Negative 2 bracket. Then we have x plus h all squared minus 1. Right? What do we do next? So okay, f is a function of x plus h is equal to minus 2 into multiply these two brackets out, x plus h and x plus h minus 1. So there's two of them. So f is a function of x plus h is equal to negative 2, multiply this out. So you have x squared plus 2hx plus h squared minus 1. This is what we have. Then finally, we have f as a function of x plus h is equal to minus 2x squared minus 4hx minus 2 h squared minus 1. So we do have f at x plus h, we do have f of x. So we can just substitute on this thing here. So say the derivative of f at x is equal to what? The limit is h goes to 0 of what? Of this f at x plus h, which is this thing here. So what do we have? Substitute this thing, which is negative 2x squared minus 4hx minus 2h squared minus 1, right? Minus f of x, which is, what is f of x? You are given that f of x is this thing here. Minus 2x squared minus 1, all divided by h. So, let's go, let's simplify. Multiply this bracket out. So you have the derivative of f at x is derivative of f at x to equal to the limit as h goes to 0 of what? Of negative 2x squared minus 4hx minus 2h squared, right? Minus 1 plus 2x squared plus 1. All divided by h. So you group the like terms, this one and this one go away, this one and this one go away. So you're left with f prime at x to equal to the limit as h go to 0 of negative 4hx minus 2h squared all over h. When you're here, just factorize. Take out the common factor. So we have f prime is a function of x. F prime at x actually. Equal to the limit is h go to 0. So we take out the common factor, which is h. So we're left with minus 4x minus 2h all over h. So this and that go away. So we're left with f prime at x to equal to the limit as h go to 0 of what? Of negative 4x minus h. Then you just allow your h to get close to 0. So, which means you will have something equivalent to f prime at x, it's called the limit, actually, is equal to negative 4x minus 2 into 0. Therefore, f prime, which is the derivative at x, is equal to minus 4x. This is what we have. Done. So, you've found your f prime, which is the derivative of f with respect to x using first principles, which is using the definition. We're done. I hope it does make sense. So let's move. We're going to 7.2. So that's saying now, determine 7.2.1. Point 1. So now we're doing 7.2. 7.2, they are saying determine f prime at x if it is given that f of x is that. So they wanted to find the derivative of f, right? If it is given that f of x is that. So they don't want that from first principle, just derive. You don't have to use first principles. You can, but you don't have to. So we just derive normally. So we have f of x to equal to minus 2x cubed plus 3x squared. So the derivative f prime at x is equal to be 3 times this. So negative 2 times 3, right? Then you have your x cubed, then you subtract 1 plus your 3 times that 2, then you have your x raised 2 minus 1. So your f prime at x, the derivative of f with respect to x, is equal to negative 6x squared plus 6x. So this is a derivative of f with respect to x. So move 7.2.2. That's saying determine dy dx if it is given that your f of x is equal to if it is given that your y is equal to 2x plus 1 over square root 4x. That's what they wanted to do. They wanted to find the derivative of y with respect to x if y is that. So we know that first thing, we can derive if we have a root like that. We have a square root there. We can derive if we have a variable under the square root, right? Also, we cannot derive these things if we have a variable as a numerator, it is a denominator. So you need your variable x to be your numerator, right? So let's sort that out. So let's get rid of that bracket, of that square root first. So your y is equal to 2x, this have no problem, plus 1 over, I said loss, square root of 4 times square root of x. So we haven't sorted our square root problem because we still have a variable under the square root. So we have to convert that variable, that square root, into an exponential form. So what we do, or power form. So y is equal to 2x plus 1 over square root of 4 is 2. X raised 1 over 2. Because if you have a square root, there's 2 there, there's 1 there, so it's 1 over 2. Then, now the problem is that the variable is still a numerator. So we can take it up. So by saying y is equal to 2x plus 1 over 2 times x raised negative 1 over 2. So when we are here, we don't have any variables in numeric, all of them are up here. So we can derive the same way we did here. So the derivative of y with respect to x is equal to, you say 2 times the exponent, which is 1, then you have x, 1 minus 1, plus, what do you have? You have your 1 over 2 times negative half, then you have x raised negative half, and you subtract 1, the way you did here, the way you did up there. So the derivative of y with respect to x is equal to 2, right? Because this is 0, so this will be 1, plus or minus 1 over 4, x raised negative 3 over 2. So that is your final answer. So it should look something like this. We're done with 7.2.2. Looks like we have 7.3. So I'll clean the board and then we do 7.3. I'll just clean this side. Okay, so now we're doing 7.3, right? So 7.3 reads as follows. The graph of f prime has a minimum turning point at 1 and minus 3. Determine the values of x for which the graph is concave down. Let me read this thing again. They're saying now, the graph of f prime has a minimum turning point at 1 and minus 3. Determine values of x for which f is concave down. No problem. So, now, I'll assume that f, your function f here is cubic. I'll assume that it's cubic. So now if you derive it and get f prime is what? Is your quadratic function, which is your parabola, right? If you differentiate again, find the second derivative, it will be what? It will be a straight line. That's what you'll get. That's what you'll get. No problem. So what do we do? So we're saying that this has a minimum turning point there. Which is this one has a minimum turning point where? At that point. So I'll just try to make a table like this. So if you equate this to 0 and find its roots, what will they tell you? The roots of this, of f of x equal to 0, will give you what? The x-intercepts of what? Of f. That's what those things will give you. If you equate f prime and x to 0, find the roots. What will the roots tell you? The roots of this will give the turning points of what? Of f, which is the original function. So if you derive this and equate it to 0 and find the x values, what the x values that you'll be getting will be the x values of your original function f. No problem. If you derive this, get the second derivative of f, equate it to 0, and solve for x, the roots, what will they tell you? They will tell you, the roots will tell you what? They will tell you the point of inflection where the graph changes concavity, right? That's one thing. Also, they will tell you where f prime, which is this function here, is turning, which is, it will give you the x-coordinate of the turning point, the x-coordinate of the turning point of this one, of the parabola. So let me repeat this. I'm saying that if you have a function f, which I'll take it as cubic in this case because you guys work with a lot of cubics, and equate it to 0 and solve, find its roots, which is its solutions. The solutions that you'll be getting are the x-intercepts, right? If you want the second derivative, equate it to 0, find the roots. The roots that you'll be getting here will be telling you the x-coordinates of the turning points of the original function. Problem. The second derivative, you equal it to 0 and solve for x. The x-coordinate that you'll be getting will be that of the point of inflection, where your graph changes concavity. So, what does this mean, point of inflection? So, if your cubic function maybe was like this, let's say your cubic function was like this. Let's somewhere here, you can see that it had this shape here. So when it had this shape, it's started to be concave down. When it had a shape like this. When it had a shape like this, it is said to be concave up. So after some point here, you can see it is concave up somewhere here. This side. So this side is concave up. You can see it has a shape that is U-shaped. So it is said to be concave up. So we want the x values where this thing is concave down. That's the x values that we're looking for. Right? No problem. So the roots of the second derivative give you the point of inflection and the x-coordinate of the turning point of this one. So we know the x-coordinate of the turning point of f prime, that it's 1. That x-coordinate is also the point of inflection. So at x is equal to 1, we have the point of inflection at x equal to 1. Why am I saying this? Because I'm saying this because if you find the roots of the second derivative, they tell you the point of inflection and they tell you the turning point of your gradient function, which is f prime, which is the parabola. So we're given the x-coordinate of the turning point to be 1, which is what I'm saying is the point of inflection. And they told you that this point is at a minimum of this function, is a minimum value of the gradient function. So it's the minimum gradient, right? So what does that tell you? If it is the minimum gradient, which means your gradient function have a shape that is more or less similar to this. So where we have what? Your 1 here, and here you have your -3. So your coordinates here is 1 and -3 of this point where? Here the turning point. So now what we do is we'll have to draw the concavity function, which means this straight line here from this one. So because this one is positive, so the straight line will also be positive. So it will have a shape like this. Right? So this is the concavity function. This one, concavity function. And this one here, the black one, is the gradient function, which is the f prime. So I'm not sure if I have to write it, but let's do. So this one here is the gradient function. So what do? We say now, okay, we want our function where it is concave down. So if it is concave down, what does that tell us? It means f prime at x should be less than 0, which means where our function is negative, the red function should be less than 0. This means concave down. So where is it concave down? It is concave down here. You can see it here. Where are the corresponding x values? The corresponding x values are all the x values this side. So how do we write this concavity? You say it is concave down for x is an element of -infinity to 1. You don't include 1 because 1, it is not concave down. It changes concavity there. So these should be x values where it is concave down. Or 1, just simply write it as x is less than 1. Because all the x values on this side, which is on the left hand side of 1, our function will be, concave function will be less than 0, which means it is concave down. If you want it to be concave up, your f prime should be greater than 0, it should be all the x values on the other side. So this is how you answer this question. And I hope it does make sense to you as it does to us. And if you did find this video helpful, please consider to let us know in the comment section. Like the video and perhaps subscribe for similar content if you are interested in it. Until next time, so yeah, we're done. Thank you for watching. Cheers.